Hi everyone, welcome back to my channel Young Researchers. Today we are going to discuss about fitting of non-linear Temkin Isotherm model in origin. So for non-linear fitting of Temkin model, we have to take on CE and QE data on X and Y axis respectively. So generally that term, or you can say like the notation that is used in Temkin non-linear equation, it is written as C, or for QE you can see in different papers like they mentioned QE as N. So both QE and N represent the same adsorption capacity, equilibrium adsorption capacity, but the notation for its presentation is different in different papers. Okay, so just the CE will be termed as C and the QE will be termed as N, or else you can keep it as CE and QE will be represented as N. Okay, for now you need to take the concentration on x-axis and N or QE on y-axis. Once you have taken the data in worksheet, you will select it and then go to plot option here, and here you can select the scatter plot or line plot depending upon your choice. Since we have already drawn scatter plot here, so you can see this is the C data and this is the N in milligram per gram we have taken, and now we want to apply the non-linear Temkin fitting on this data. For that we will click any of the data point and then we will go to analysis, and from analysis you can see the option of fitting, and here you can see non-linear curve fit, and from here you can select open dialog. Once it is opened, you can select the category as origin basic function for the first time user, and from function, if you are using it for the first time, you will scroll it down and then select new. Or if you have already added the expression into the origin data set, then you can select the from name whatever the name that you saved last time. For a new user, you will click on new and then this box will appear to you. Here you need to mention the name of the function. For example, if I keep it as Temkin MB, then the file name will automatically be changed the same as the function name, and then we will click on the next. So independent variable, since here it is C and the dependent variable is N, and the parameters that we want to calculate from Temkin model graph, they are A and B. They are both constant of Temkin isotherm, and we have discussed about A and B constant, what they are, what they represent, and we also discussed about their units and interpretation in our previous video regarding the linear fitting of the Temkin model. So you can check the previous videos of this playlist. Okay, after that you can click on next option here. Yeah, and here it is the function body. You need to mention about the equation non-linear expression of the Temkin model here, and the non-linear expression of Temkin, it is written as N equals B multiply. For multiply we will use the sign steric and then natural log and then small bracket. It will be with A into C and then small bracket close, and after writing this expression, this is the, please note it down, this is the expression for non-linear Temkin model. You can find it its reference in different research and review papers in literature. Okay, after that you can click on next option, again next, and here you need to select the lower limit boundary for A and B parameters. You will double click on each option here until this less than symbol appears to you, and then we will select the boundary as 0. So we selected the boundary that our A and B values, it must not be less than 0, like we are saying to the system of origin that the values of A and B constant, it must not be in negative values. Okay, so we have selected our limit here. Only for lower boundary, not for upper limit. Can vary, very small value, it can be very high value depending upon whatever the fitting results are we obtained. Okay, after that you can click on next option here, again next, and then finish. So the equation or expression has been added to the system. Now you can click on the fit option here, then you can see this line has been added to the system, and this is the Temkin non-linear Temkin model fitting to the experimental data. And if I make it larger, you can see the value of A constant is 0.352 and the B constant is 34.87. Generally the value of B, that is a Temkin constant, it is generally greater than the value of A, so there is nothing to worry about. These values are okay, and you can see the value of R square is 0.965, so it is also good or close to 1. So you can change the color and width of this line by clicking on this, and you can make it more wider as 2 or 1.5 or 3, and you can change the color from here as well. You can make it blue or black or whatever the color you want to make it. You can change its style as well. Okay, so this is the nonlinear fitting of Temkin Isotherm model to your experimental data, and here you can see the equation as well. So you can keep this graph in your paper and explain it like uh, you can apply it along with linear model as well. So then you can compare both linear and non-linear models, isotherm models with each other, and then describe which model fit best to your experimental data, either linear or non-linear, and what those models describe. Okay, so this is all about today's video. In coming video we will discuss some more interesting isothermal models and their non-linear fitting in origin. Okay, so till then, Allah Hafiz.